All right, hopefully I got that going. All right, let me go find my notes. I should have had those pulled up. All right, finally. We are moving on to this one page. If I can get to it. It's been a long unit, I feel like. All right, we're going to do this one page, applications of the ideal gas law. And there are a couple of formulas that go with this, which you will probably need to kind of correct or finish on your formula sheet. Is on one side of your formula sheet, is there like at the very top, a couple of formulas that are kind of cut off? Yeah, so let's remember to be sure that we get those. We'll get to that point. All right, so this is applications of the ideal gas law. All right, so since we're applying ideal gas, our volume is still going to have to be in liters, because if we're using the ideal gas law, then we're going to be using that ideal gas law constant. It's a very messy liters. And temperature still in Kelvin. And then also you'll be using your R. Remember, that's going to be based on the pressure. Unless you choose to change your pressure, always to atmosphere and kind of use that most common one. All right, so we are going to be looking at molar mass and density of gases and how we can find that. So my first one is going to be molar mass is equal to dRT over P. And we've used all of those before. We've used D, that stands for density, but it's been a while. R is still our gas constant, P still pressure, T is still temperature, and M is still molar mass. Y'all have this formula on, you're going to have this formula on your reference sheet, but if you were in AP Chem or I don't know about college Chem, this is not on that reference sheet. So it is called or one way to remember it is the kitty cat equation. Can anybody guess why it's called the kitty cat equation? Because cats like to put dirt over their pee. Bet you won't forget it. So that's why it's called the kitty cat equation. So dRT over your P. The other one we're looking at is density, and all it is just this rearranged. That's going to be molar mass times pressure divided by my R and my T. All right, so we haven't done density in a while. Density is mass divided by volume. And your mass would be in grams. And your volume has to be in liters. But other things that would alert you as a volume measurement would be milliliters, centimeters cubed. And remember, those are equal to each other. So you would have to change your decimal and get it to liters. On that, oh no, y'all haven't done the work yet. I keep forgetting. Molar mass is grams per mole. We've used that before. We've used it a couple of times on the gas law work. That is what you have to use to be able to get your bonus today. So if you're given the grams of the gas, the total grams, and you have enough information to put in the ideal gas law, then you can figure out your moles, and then you would just take that grams divided by how many moles you need. All right, so let's just work through a couple of those problems. It says, what is the molar mass of the gas if we have a density of grams per liter. So my volume's in liters like I need it. 729 torr. And then my temperature would become 333.0 K. All right, so I think I have everything I need. And so I just can use this formula and just fill in. So molar mass is going to be equal to my density, which is 2.75 grams per liter, times my R. So my pressure's in torr, which is the same thing as millimeters of mercury. So if you look at your R values, you would use the 62.4, and that's liters per torr divided by mole times Kelvin. And then the last thing I have would be my temperature, which is 333.0 Kelvin. And what do I need to divide all of that by? My pressure, 729 torr. So I know that's a lot of units. I'm just showing you how they cancel out on this one. After that, I probably won't write all those units. But if we look at this, torr cancels, liters cancel. That's why your volume has to be. Kelvin cancels. And the only thing I'm left with is grams per mole, which is what you need as your units for molar mass. All right, so now you just multiply across and come back and divide by your 729. And then how many sig figs would you need? 3. Yeah, everything's pretty much 3 on there. So what did we get for that one? 78.4 grams per mole. So like I said, just kind of filling in a formula, kind of like our other gas laws. So maybe take a minute on your reference sheet and go to the top and make sure you have both of these formulas clear before I forget about that. I think it just cuts off a little piece of it. All right, so the next one, we're still trying to find the molar mass. It says of a gas that is 754 milliliters. I'm going to go ahead and change that to liters. 754 liters. Has a mass of 12.8 grams, 102.5 kilopascals, and my temperature would become 358.0 K. So if I look at my formula, I'm going to mark on my formula, don't mark on yours. We're trying to find molar mass. I have my pressure. I have my temperature. I have my R. I don't have my density. But do I have the information I need to get density? Yeah, because density is mass divided by volume. So you kind of have to do a little, what I call a little side calculation. I'm going to take my mass and I'm going to divide it by my volume in liters. Both of those have 3 sig figs, so I want my answer to have 3 sig figs. Hopefully we got 17. 17.0 grams per liter. So now I have everything, so I can come back in and fill in my formula. So I'm going to say my molar mass is going to be equal to my density, which is what I calculated. So that would be my 17. What is my pressure? My pressure is in kilopascals. So I'm going to use my 8.31, and then my temperature, 358.0. Come back and divide all of that by my, did I do something wrong there? No. Okay, by my pressure, which is my 102.5. Now, see, I left off my units there because I know that my units for molar mass has to at the end be grams per mole. So you can do which one you choose to. Most of the things we do in Chem 1, you can kind of memorize what the units are. AP chemistry, sometimes you have to work with it a little bit more. All right, how many sig figs for our answer? 3. So what did we get? 493 grams per mole. All righty. Any questions on that? Did we have anybody get the bonus today? Oh, we didn't put units. So sometimes I'll give you that kind of question. Maybe you'll see it on the test. Let's say that you did all your calculations correctly and you found out that the molar mass of the gas that was being talked about was 28 grams per mole. And then I asked you as a question to tell me what gas that is. Anybody want to take a guess? What? Okay, so that's silicon and it looks like it's that, but now think about this. What state is silicon in at room temperature? If it's black up there. Solid, right? So can we be talking about silicon? It is nitrogen. Don't forget your diatomics because 28 would be 2 nitrogens. Y'all got it back there. Same thing as if you would have figured out 32, that would have been oxygen because it's diatomic. But usually people kind of get going fast and they just pick out the closest one. Pretty common, but anyway, I just wanted to bring that up because I usually throw in a bonus or so on the main test too. All righty, let's just work the other formula and move it up a little bit. All righty. So I'm just going to rewrite my formula here because I can't see it anymore. Molar mass times P over RT. All right. What is the density of 3 moles of a gas at 2.3 atmospheres? Temperature's already in Kelvin. And then I have 15.9 grams. So once again, if I go through that same thing, I have my pressure, I can always have my R, and I have my T. I don't have my molar mass given to me, but do I have what I need to get my molar mass? Yeah, because molar mass is always grams divided by moles. So I'm going to take my 15.9 grams and divide it by my 3 moles. Those are both 3 sig figs. So you would want your answer to have 3 sig figs. So what do we get for that? 5.30. Got to add that 0 on there for 3 sig figs. Or realize that you didn't and make your adjustments at the end because obviously that 0 is not going to change your calculation. So now we have everything we need. So I'm going to start filling in. My molar mass was my side calculation. My pressure was my 2.31. My R 0.0821. It's the only one I have memorized. So I like when it's in atmospheres. And 311 was my temperature. And I think even at the end, we still need 3 sig figs. So what do we get for our density? 0.479. And then my units would be grams per liter. So anybody have any questions on that one? All right, why don't y'all try that very last one? Megan, do you have a question you were looking? Okay. What do I need to remember about oxygen and that problem? Yeah, that it's diatomic. Anybody have an answer they want to try? Juan, what'd you get back there? That's what I got too. And my units, because it's density, would be grams per liter. All right. Does anybody want me to work that one through? You do? Okay. So we're still going to be using this formula to find my density. So my molar mass, because it's oxygen, I know it's O2, so that would be my 32.00. And then my pressure was 1.23 ATMs. My R, because it's in ATMs, was 0.0821. And then my temperature, when I changed it, it was 308.0 K. So then we're just going to multiply and divide, and everything was 3 sig figs. So that's where I would get my 1.56 grams per liter. And once again, since I didn't plug in all my units, I'm not canceling out. So you kind of have to memorize what your units are going to be. Oh, thank you. Does that help? Okay. All right. One more thing I just want to say real quick before we stop and we get the door. So on one of our other quizzes, I know quite a few people, I saw one that quite a few people were missing. So it said, like, maybe it gave you what the pressure and the volume of our pressure and temperature originally was, and then it said it changed, the gas changed to STP. So if you look on your reference sheet on the same side that has all of your R's and pressure conversions, there's one right in the middle that says STP, and I think it says 0 degrees Celsius and 1 ATM. Now, some people, for some reason, went on that reference sheet and picked out let's see, what did they pick out? The most popular one was volume of ideal gas at STP at 22.4. We haven't used that yet. We've talked about it, but we haven't used it. So I was a little confused why people picked that one out. But remember, if the problem tells you the gas is at STP, that stands for standard temperature and pressure. So if you know a gas is at STP, that is giving you a temperature and that is giving you a pressure. So in this case, 0 degrees Celsius, we wouldn't want to use that. So we would use 273 K, not affecting your sig figs. And if you didn't want your pressure and atmosphere, you could go down to all those conversions for your pressure. So it could be equal to like 760 millimeters of mercury or torr. Okay. So that was a common mistake I've been seeing on some of the quizzes. Anybody have any questions on that? All right, you got a couple of minutes if you want to give one of your practice problems a try before we go to lunch. And like I said, we're not going to do a separate quiz on this. You'll see this on the test, which will come after spring break, either the Thursday or Friday after spring break.